Sure.
Can we go back to homework 5 and do number 2?
Absolutely.
Thank you.
Sure. Pull that out. Okay. Those guys are all going, and that thing is running. Okay. And you wanted to do number 2, you say?
Yeah.
Love it. So on homework 5, most people's that I looked at definitely didn't follow the directions on the assignment. It looked like they just used their PhotoMath app and wrote down everything that the PhotoMath app said, even though it ignored all of the directions. And like, I get that you guys have these things and use these things, but like, don't use them to do your homework. Like, if you're going to check your homework with it, or like you're like, I'm not sure quite what to do, I need to kind of figure this out, but don't write down a bunch of mumbo jumbo that you don't understand anyways. Because the factoring techniques you're using were things that like we didn't teach you. You really didn't have any reason to know those. I don't think that like they're practical factoring techniques because they're pretty specific to the individual problem. So like I get that you can use these apps to like do your homework, but that's not the purpose of them. The purpose isn't to get your homework done as fast as possible. It should be to kind of like help you learn what's going on. Okay? So like I know you're using these things and like I get it, but like use them in a way that's productive as like a checker, not necessarily a doer. Anyways, I don't know. I wasn't directing you specifically, Ben. I was just there. I mean, more than half the class I probably marked down and gave some kind of comment about didn't follow the directions for this assignment. I don't remember what you did or didn't do, but I'm guessing that you need to, like we need to do this anyway. So let's go get going on this. Okay. So number 2, it says include the number of solutions. So we do that using the fundamental theorem of algebra. Oops, and you guys can't see what I'm writing down, so let's make sure I change the projection to cover that. My apologies. I'll take a second and do that. And that's really easy to do because whatever the degree for the polynomial is tells you the number of solutions. So since this is x cubed, I know there's 3 solutions. Then it says the possible rational solutions. So to do that, I'm going to use the rational roots theorem, which is just says to take the factors of the constant term divided by the factors of the leading coefficient. Since the leading coefficient is 1, it doesn't really matter because anything divided by 1, it's still itself. So I really just need the factors of 12. So that's positive and negative 1, 2, 3, 4, 6, and 12 are all the things that divide 12. And then it says, from looking at the graph, indicate the likely rational solutions. So I'm going to go now and fire up my graphing calculator and plug this polynomial into the graph. So I press the y equals button. I'm going to clear out anything that was in there, and I'm just going to type this in exactly as it looks on my sheet of paper. So I'll do x cubed minus 13x plus 12. And then I'm going to set my window. So my window should be set from the biggest to smallest things on my RRT list, which is positive and negative 12. So the x min should be the negative 12, and the x max should be the positive 12. And then I'm going to hit graph. Okay. So I can't quite read where these are crossing on the x-axis. That's what I'm interested in, are the x-intercepts. So I'm going to zoom in a little bit. I notice there's nothing going on out here and nothing going on out here. So I'm just going to knock the window down to like negative 6 to positive 6. So it looks like I have a -4, a +1, and a +3. So far, so good, Ben?
Yeah.
Okay. Are you good with the calculator parts and everything?
Yeah.
Okay. Again, if I go too fast through something or there's something you don't like or don't understand, stop me and I'll be happy to go slow down or re-say it or whatever. Now, to figure out if these are rational or not, all I'm going to do is check to see if they occur on my RRT list. So, for example, -4 is there. So that tells me that one is rational. +1 is there. So that one should be rational. And +3 is also there. So that one should be rational. So far, so good. Since they're all rational, any one of them would be good candidates to do the synthetic division with. Since it doesn't really matter, I'm just going to use the first one. So I'll set up my synthetic division. Note that I included that 0 there. Why did I put that 0 in my synthetic division? Anybody? Woody? Yeah, since there are no x squareds in my polynomial, I need to put a 0 where the x squareds would go. Really important that you remember to do that. You don't always have to do that, but on the problems where you do, there's no recovery if you forget to do it. Like, you will not get the right answer. Things will not work out right. You'll be banging your head against the wall going, why the heck isn't this working? So let's go ahead and do our synthetic division. So we start by bringing the first number down, and we take the number on the outside, multiply it to the number underneath, write the answer in the next open spot, and then add down. And then we just continue that process until we've filled up all the spots. Now, what we're hoping for is that the remainder was 0, which is what we got here. These others represent, starting from the right, the constant term, the x coefficient, the x squared coefficient. We just keep counting up by degree as we go. So what this tells me is that since -4 gave me a remainder 0, that x plus 4 is a factor. And then the leftover part, x squared minus 4x plus 3, is my other factor. Okay, so with that so far, Ben?
You kind of lose me at that point.
Okay, so like, let's just do this with numbers for a minute. So if I have 12 and I divide it by 3, it's 4, right?
Okay, I see what you did there.
So that 3 times 4 is 12, right?
All right, yeah, I got it.
So since x plus 4, or I'm sorry, since x cubed minus 13x plus 12 divided by x plus 4 gives me x squared minus 4x plus 3, I know that it factors to x plus 4 times x squared minus 4x plus 3. Does that make sense? Okay. So now, the part that's left over, the x squared minus 4x plus 3, that piece is factorable. So I could stop doing synthetic divisions at this point and go back to my factoring tree method, because I recognize that that's like a chapter 4 factoring problem that I should be able to do relatively easily. Or you could continue doing synthetic division and try dividing with the +1 or the negative, the +1 or +3. That would be fine to do as well. It doesn't matter which way you go. I'm going to go ahead and just factor this like we would have last semester. So multiplies to give me a +3, adds to give me -4. That would be -1 and -3. And there's my fully factored piece. Maybe I'll write it that
What's
way.
that last one? The x plus 3.
It's a minus. Does that feel a bit better?
Yeah.
So that's the process that I was hoping that you would use and the work that I was hoping you would show on these problems. So again, if you got marked down on this and you want to redo it following the directions, you're welcome to do that. Just send me an email, let me know if when you finish so I can remember to go back and look at it. Alexis? Okay, so it probably is the opposite, but by looking at the graph, you can't tell the difference between like 2.9 and 3, right? So the only way you know that actually 3 is the factor that you need is to do the synthetic division to show that, yeah, I'm positive this is a factor. Up until that point, you just are pretty sure it's a factor. It's necessary that you do that step. It could sometimes not work out. Like it's possible. Now I haven't given you a problem that's that ambiguous, but like I think on number 5 there was something that was an x-intercept that doesn't translate directly into a factor. So like it is possible that that kind of stuff happens, and you don't know for sure that it's not the case until you do the synthetic divisions. Now on this problem, you should have been almost positive that like I know exactly what this is going to factor to look like. But you do still need to do at least that first synthetic division to get it down to a place like, okay, can factor from here, and yes, everything matches up, and I know I'm 100% right. You know what I mean? Do you see the difference there? Yeah. Okay. And it's a fair question, right? Like, because up until this point, basically every one of the x-intercepts we see is a factor. It's like, why are we bothering to do this? I have 3 x-intercepts. I know there can be at most 3 factors. Like, why bother with the synthetic division? And that's a fair question, and I hope that I gave you a reasonable answer to that as to why we still need to worry about it. Okay. Haley, right?
Yeah. Number 6.
Sure. You're welcome. So I'll pick a new color here. We'll do green or something. Okay. For number 6, we have 5 solutions, right? We can tell that square away just by looking at the x or the degree. Good with that? Okay. Then we'll go to our RRT. So we're going to have the factors of 8 divided by the factors of 1. So really we just care about the factors of 8, which are 1, 2, 4, and 8. And then we go to our calculator. So let's go ahead and go to our calculator. So I'll open up the y equals menu, clear out whatever was in there, and then type in my new polynomial exactly as it's written on my sheet of paper. So I got that in. I'll go to my window now. I'm going to set this, the x min and x max, to be -8 and +8, the biggest and smallest numbers from my list. So the x min has to be the -1, the x max has to be the +1. And then we'll hit graph. Oh my gosh. Zoom, go away. I don't want you up there. Okay. So I look at this, and again, I'm looking for x-intercepts. So it looks like there's something going on here between -1 and -2. but I can't exactly see, is it crossing there once, twice, 3 times? It looks pretty flat along the x-axis there, right? Do you agree with that, Haley? Okay, so I'm going to take a closer look at that area. So I'm going to zoom in between negative 2.5 and negative 0.5. And I also need to, this time, change my y coordinates because I need to get a really close look at this. So I'm going to change this, my y min I had at negative 3. So I'm going to change it to like negative 0.1 and positive 0.1 because it looked pretty flat along the x-axis. I want to get a good close look there. Okay, so that helped out a lot, right? Because now I can clearly see negative 2 and negative 1 are my x-intercepts. Do you agree with that? Okay. And I see that both of those are on my RRT list, so they're both rational. But at this point, I should think that there's maybe something fishy going on, because I should be seeing at most 5 factors. I see just 2 right now, right? Now, in the previous problem that we did, I had 3 solutions and I had 3 x-intercepts, and that looked great. You know, there's little ambiguity there. Here, I have 2 x-intercepts, but I have 5 solutions. Where are the other 3? Well, there's a couple of options. They could be imaginary, right? You're never going to be able to see the imaginary ones on the graph. Or maybe you have some duplicate solutions. So maybe like x equals negative 2 is a solution that occurs more than once. Or similarly with negative 1, maybe they occur more than once. We don't know that yet. In the previous lecture that we gave, I told you guys how to determine that by looking at the graph. So let's do that right now and just use a little bit of, future knowledge there. So when I look at the graph, I'm going to look at these x-intercepts and determine if they're bend, bounces, or straights. Okay, you remember doing that last time, Haley? Okay, so if I look at negative 2, is that a bend, bounce, or a straight? Where it curves one way and then curves the other way, right? You see how it's curving this way and then changes and starts curving the other way? That's a bend. You can see that? And then this one that like hits and goes back the other direction is a bounce. So let's write that down. So bends could be used an odd number of times, at least 3, so like 3, 5, 7, etc. Bounces are an even number of times greater than, or at least 2, so like 2, 4, 6, etc. But I know that really I can't be used 6 times or 7 times because I only have 5 solutions that I can use. And in fact, I know I can't be used 4 times because this one is still being used 3 times. And I can't be used 5 times because this one is still being used twice. So it really has to be 3 of one and 2 of the other. Does that make sense? Okay, so that's what I'm going to, knowing that, starting my synthetic division makes life a lot easier. Now, you didn't know that when you did this assignment. I would have expected most of us to done the 2 divisions and then gotten stuck and go, whoa, what do I do now? And maybe one of you would have just thought, let's just try one of these again. And if you did that, everything worked out. But that's okay. So I'm going to do negative 2 first. It doesn't matter whether you start with the negative 2 or the negative 1. So I'm just going to kind of burn through that here quickly. And I know that this could be used 3 times, so I'm not even going to bother to stop and look at what I have. I'm just going to go ahead and do it the 3 times. Cool there. And now what I can say is, okay, I have x plus 2. And because I did that division 3 times, I'm going to have 3 of them. And then I have an x squared plus 2x plus 1. And that piece I can factor, right? I stopped here because I had 3 terms left. And I knew that that was going to be something that I could factor using the factoring tree. You could have kept going and doing the synthetic divisions, though, if you wanted to, Haley. That would have been okay also. So what this says is, or what I have to do then is multiplies to give me 1 and adds to give me 2. Well, that's just 1 and 1, right? So there's my final answer. I would have written it this way if you prefer. This is the way I like to write them because it's less writing. But either answer is okay. You know. So both of those answers would have been okay. Did that help?
Yeah.
Yeah. So again, doing this problem when we did it on the first time when you didn't know about the bend, bounce, straight thing was going to be quite tricky. This was actually going to be the jumping off point for me to start talking about the bend, bounce, and straight, assuming that somebody was going to be like, yo, what was up with number 6? I got like 2 things to work, but then what the heck do I do after that? And that was going to be kind of my prompt into introducing that new theorem so that you could kind of see how useful it could be in a setting like this where it was unclear what to do. Does that feel better, Haley?
Yeah.
Of course. Okay. So I think, yeah, Hallie. Sure. Yeah, but you know this is all in the content library too, right?
Yeah.
Okay. Yes.
I know that.
Of course. Okay. So number 1, you say, okay. So I know right away that I have 3 solutions, right? I'm sorry, you said something and the mask and you kind of mumbled and trailed off at the end. I just missed it. Can you repeat yourself?
Yeah, I just think like the constant, the negative, like the negative.
Doesn't matter. We don't care because the factors of negative 20 and the factors of positive 20 are the same factors. Because if I divide it by 2 or divide it by negative 2, either one's going to give me a remainder 0, right? You agree with that? So they're both factors. Whether it was positive 20 or negative 20, didn't matter to us. So again, our factors of 20, 1, 2, 4, 5, 10, and 20. I'm going to go type that in then to my calculator and look at the picture. Hallie, what's up? I can hear you asking questions. You can just ask them to me too. Alexis?
No, Haley asked me a question. I just asked a question of that. I said it low.
Oh, okay. Sorry. Jeepers creepers, you guys. Don't get so mad at each other. It's okay to ask questions. You could have just been like, it was a question about the content library. It's like, okay, that's not a big deal. I'm just trying to be approachable, you know? I'm not trying to make anybody uncomfortable. I realize it's getting uncomfortable now because I keep talking about it, but...
It's all right, Mr. Cool, you're the goat.
I'm the goat, huh?
Mm-hmm.
Okay. So I do the graph, and most of this is not useful to me, right? The ends are both garbo. You agree with that? But it's not like I can read what's going on there. I'd estimate this one is maybe -5 and this one's maybe +5, but I'm not quite sure. So I'm going to pick a little bit more than that, maybe -7 and +7. I'm just kind of guessing and eyeballing. but I just want to make sure I can see them crossing. So I see here I have -1, -5, and then +4. Allie, you good with that?
Yeah.
And you notice that they're all straight, so they're going to be used exactly once. Let's see, 5, 1, 4. And each of them are on my list, so they're all rational, and they're all seats. So really, any one of them would be a good choice to start my synthetic division with. I'm going to start with the -5 just because it was the first thing on my list. It doesn't really matter. You could have started with any one of them. -1 might have been a good one to use too because it makes the arithmetic pretty trivial when you do the synthetic division. So then I'll do the synthetic division. And that worked. So instead of stopping here, let's factor or do another synthetic division. You could stop and start factoring by hand, but if you like doing the synthetic division, you can keep going and do another synthetic division. Like I'll stop here and go to -1. I've already used -5. And that worked. And now that I have two terms, this is really quite simple. Right, I have the x plus 5, because when I got remainder 0 there. And I have the x plus 1, because I got the remainder 0 there. And then I have the x minus 4 from the left over at the end. So if you don't like factoring by hand, and you still have things left to do on your x-intercepts list, you can keep going and do another synthetic division if that's easier for you than the factoring by hand. That's okay to do it that way also. I know some of us might prefer to do that, might be better at synthetic division than they are at factoring by hand. That's okay to do it that way also. Allie, did that cleared things up for you? Sure. Okay. So I'm going to stop here because